Alright, so the last thing we were doing was respect to arrays. What we're going to go on now to is respect to strings. And any collection of sequential characters is typically referred to as string in any sort of programming language. So before we move on to C++ strings, we need to know about C-style strings, which is basically an array of characters that uses a null terminator. And this null terminator basically indicates the end of the string. So, for instance, if we need to create a C-style string, we'll make a character array here. And then we enclose the contents of the string in double quotes. And typically, because even though this myString character array only has 6 letters, because it's a C-style string, it automatically adds a null terminator to the end of the string for us. So consequently, this array actually has a length of 7. Now, when declaring C-style strings, being that they are just character arrays, it's a good idea just to use the square brackets here and don't specify a length, so that way the compiler could actually calculate the length of the array. So that way if you change the string later, you wouldn't have to manually adjust the array length. And these strings also follow the same rules as general arrays, because you can only initialize it upon creation, but you cannot assign values to it using the assignment operator afterwards. And because you are using those square brackets operators because it's an array, you can actually change individual characters in the string. So for instance, let's say I wanted to change the character at the number 1 position in the string. I can do this. And then if I output the string, so let's compile our code and see what happens here. We should get spring instead, which can be seen here. So remember, arrays start at position 0, and in this case we are changing the character at position 1, which is going to be this T character here. So replace that T here with P, and that's how we get from string to spring. Now, typically when you print a C-style string, the cout function will print the characters until it encounters a null terminator. And if for some reason you accidentally overwrite the null terminator in the string, you will not only get all the characters in the string, but it will just keep on printing out a whole set of nonsense, because it doesn't know where to end. So it will just keep on going into random memory slots and printing whatever there is inside them. Now, there are in some cases where you may not know what is the length of the string in advance. And a case like this would be like if you're expecting the user input. So it's possible for you to declare an array larger than what is needed when you're doing this. So for instance, we can say char name. Let's say we want it to be a length of 255. And then we can ask the user here to enter their name. And then we accept the input. And we can then see if the user actually entered their name by outputting it back to the screen. Alright, so let's try this. Let's say enter your name here. Alright, so in this case I'm gonna have to break point because of how Visual Studio 2017 works. I'm gonna have to start with debugging. So I'll enter my name here. And you see it throws back my name exactly as how I entered it. So the assumption here is that the user isn't going to enter more than 255 characters. But however, this is poor programming practice because nothing is stopping the user from entering more than 255 characters, be it by accident or by some sort of malicious nature. And one thing to note in particular, if we start back this program again, let's say if I wanted to add my full name. What you want to notice here is that it only accepts my first part of my name, so my first name. It doesn't accept my last name. And it's because the cin function, once it sees a space, it just automatically stops reading anything in particular. So there is a proper way on how we can actually accept strings with spaces in particular, which I'm going to show you now. So this is the recommended way for how we should actually use strings, especially when they have spaces in them. So instead of using cin, we're going to use the getLine function, which is a part of cin. And then the first thing we do is we specify what the character array is inside its function as the first input to its function, and then the length of the character array afterwards as the second input to the function. So let me break point here again. So if I type in my full name here now, right, so my full name here will actually be printed out to the screen because the getLine function accommodates for spaces. And the call to the cin getLine function will read up to 254 characters into the name, and the 255th character is going to be the null terminator. And for some reason, if someone tries to enter more than 255 characters, all the excess characters will just be discarded. And this will guarantee that our character array here will not overflow whatsoever. Alright, so that's it for C-style strings. Let's move on to C++ strings. So if we intend to use C++ strings, the first thing we need to do is include the string library. So we hash include string at the top of our program here. And then all variables that are type string, we can actually declare them as part of the std library because we know we have included the string library here. So for instance, we can say std string my name. We can also say std string my name, and then we can initialize it immediately using this. We can also say, after we just declare my name, we can then initialize it afterwards, like this as well. And one thing to note is that, let's say we assign a number to a string. Remember, this is not an integer, this is characters. So 45 here are characters, and it's not the same as an integer 45. So just like any normal variables, you can initialize or assign values to strings as you would expect. And strings can hold numbers as well, but in this case they won't be number format, they will be character format. So numbers here are treated as text, and it cannot be manipulated as numbers, meaning that you can't do any math with them. And C++ will not automatically convert string numbers into integer numbers or any floating point values that you may expect to use later on. So let's say, for instance, you wanted to output your string. It's the same way that how you were doing it before for the C-style string. So you just call cout as expected. So, right, so as you can see here, because we call the cout function here, it will just display the contents of the string accordingly for us to the output string. The same holds true for when, for some instance, let's say you wanted to accept a string with spaces instead. If you use the cin functionality here, so let's say cin, enter your name, and std cin, my name. Let's spell this. Right, so the same holds true from when you're using the C style strings, that if you just use cin by itself, anything here with a space, oh, whoops, I should need a breakpoint here. So any string here with a space, when you're using the cin functionality, it will only read up to the characters before the space, and it will ignore all characters afterwards. And this is because of how the cin function works. So similarly to when you're using the C style string, you're also going to have to use the getLine function in order to do this in particular. But you're going to have to use the getLine function a little bit differently, which I'm about to show you. So when we're using this getLine function with respect to C++ strings, we just call std : getLine. And then the first parameter of this getLine function is going to be std : cin. And then the second parameter of this function is going to be the string. So let's compile our program. And let's run it. Right, so you see, in this case, how we use getLine here, it actually accepts the space and it accepts all characters after the space. So remember, there is a fundamental difference when you're using C++ strings compared to C strings, how we actually call the getLine function. So the C string, it was cin.getLine, but for the C++ string is std : getLine. And the parameters of the function in this case will be std cin, and then the name of the string that which you're expecting to store the input in. So let's say for some instance you decide to use both cin and getLine together. So let's consider the following code here I'm going to be writing. Right, let's build this and see what happens. Let's say we picked a choice of 1. Right, so you see we don't even reach to the point where we can even enter our name as we specified in the program, because it skips waiting for you enter in your name. It turns out when you enter a numeric value using the cin function, cin not only captures the numeric value, it also captures the new line when you hit enter. So when you enter 1 in this case, it's actually 1 followed by the new line character, which is /n. And this new line character ends up getting stuck in that input stream. And when you get to the getLine function here, in particular, it still sees that new line function already in the stream, and it figures that, okay, maybe we have entered an empty string. So this is why this functionality happens, and it's a general error that happens when you mix using cline, cin, and getLine in particular. So if you absolutely have to use both of these functions for some weird reason, it is important that you need to use the cin ignore function afterwards, so that way you flush the cin buffer accordingly. And how this is that after you accept the cin part here, you call std cin.ignore, and you put a really large number here, so in this case it will be 32,767, and you say which character you're looking for it to be removed. Oh, again, because it's a character, it needs to be single quotes, not double quotes. So with this cin ignore function here, it should successfully flush the buffer and then let us input our name accordingly. Let's say in this case we do a choice of one, and we put in our full name here. Right, so it works accordingly because now, because of that cin ignore function, it flushes the buffer and it makes sure it removes that new line character that is introduced once we hit enter for the first part. So it's also possible for us to concatenate or join strings together using the plus operator or the plus equal operator. So the code I'm writing here is going to illustrate this. Okay, so let's build this and see what our output is going to look like. So our first line here, which was a plus b, will concatenate or join these two strings together, resulting in 4511. And the second case where we use the plus equal operator here, we basically say, okay, we're going to add space volts here to the result of a, and then, no, we are going to add space equal here, so we're going to append this to the end of string A, and we want to store it back in string A accordingly, resulting in how we get 45 volts here. The last thing we need to know about strings is that in some cases we may want to know how long a string is in particular. So in order to do this, we actually can call the string.length function in order to retrieve the length of the string. So in this example, our string name is my name. So if we say my name.length, we need to make sure we open and close that bracket to indicate it's a length function. This should return how many characters are within the string itself. And so when we run our program here, we can see that it returns 4 characters indicating how long the string is accordingly. So the length function is not a normal standalone function like how we've been using it previously. It's a special type of function that belongs to that string library and is referred to as a member function. And there are many other member functions of strings that actually can be found on this website here. And most of these member functions here that you're seeing, they come pretty handy when you have to deal with strings in particular. And it's quite important that you are expected to know which of these member functions are to be useful, as well as how their operation works. And this is actually quite important to when you're going to be doing your lab exam in particular. Alright, so that's the end of strings. The next video that we're going to be doing, and the next section, which is going to be our final section with respect to how we operate with files and how we're going to do the input and output with respect to them.